Hello physics students, we're going to start out and just talk about what physics is and kind of where it fits. So here are the objectives. We're going to understand what physics is about, and and then at the end the assessment will be answering this question as well as this question. So very good. So some physics terms that you will hear quite often in this course: position, velocity, acceleration, force, work, energy. And those may appear in other sciences, but certainly predominantly in physics. Okay, and physics is going to explain the physical part of the universe and try to explain cause and effect relationships that explain how it works. Okay, so Newton's laws, we'll later learn, use those to describe the fall of a skydiver, and perhaps, what makes the difference between falling to your death and surviving if you have a parachute. Physics is very important because it relates directly to technology, and we find certainly that we have become increasingly more dependent on technology. In a lot of ways it improves our quality of life. And some examples that we have here: computers, phones, electricity, microwaves. All of those are examples of technologies that have their root in physics. Alright, so physics is pretty much the most basic of the sciences. I didn't say it was easy, but you get down to how things move, why things move, and the interaction of matter, energy, and forces. That's what we're talking about rules that govern those. Alright, so basic forces, nature of atoms and matter, and the processes by which matter and energy interact. Okay, so chemistry is a higher level in complexity than physics, because we're talking about how particles and forces in a variety of compounds interact in the material world. Sometimes chemistry is referred to as the central science because it's between physics and biology. And an increased level of complexity here because you can create lots of molecules, lots of different molecules in chemical reactions. And then biology is a very high level of complexity. That's because living organisms have millions of different molecules interacting in very complicated systems. Alright, so we're going to start out and we're going to study motion, and then we'll go on maybe beyond that at the end of the course, and hopefully get into some electricity and magnetism and waves as well. But we always start here with the mechanics of studying motion. You think about, how do you build stuff like this? Well, you have to master forces and simple machines, and it wasn't understood particularly well until Isaac Newton, about 3,000 years after the pyramids were built. Alright, so measurement is going to be very important in all branches of physics. Alright, chapter 3, we're going to get into position and velocity, acceleration in chapter 4, and chapter 5 we'll do forces and Newton's laws, projectile motion in chapter 6, chapter 7 circular motion, and astronomy fits in there too. In this class we're probably not going to do the static equilibrium and torque, but we will address that in AP Physics 1 for those of you taking that class. Energy transformations, that's chapters 9 and 10. Work in energy, and then conservation of energy in chapter 10. Alright, so which statement correctly describes the science of physics? Well, it's that one. Physics is the study of matter and energy. Alright, in order for a car to stop, its brakes must apply a blank to the wheels, and blank is needed to do work, such as lifting a heavy mass. So, force and energy. And that brings us to the end. Thanks for watching.